Okay, I know that the problems for this assignment got significantly more complicated and difficult than what they had previously. It should have started to feel like it wasn't quite so easy, maybe to try to pick the formula that was matching the integral that you were given. And so here's two really important pieces of advice that I could give you when it comes to trying to pick a formula. Because I will tell you that when you pick a formula, it is not going to at first feel like it is this perfect match that I think you've experienced up until this point. And so here's two important pieces of information. One, when you are choosing a formula, try to pick a formula where instead of matching the whole entire integral you're given with the formula, try to at least match the most complicated aspect of the integral that you are given. Okay, let me give you an example. Number 26 was the most requested problem, so we're going to start there with that one. You can see number 26 here off to the side. As you look at number 26, if you were to say, do I think that the numerator or the denominator is more complicated? I think we all could agree. The denominator feels like it's more complicated. There are two terms there. This term here is to the fourth power. And so what we're going to try to do when we're looking through the list of formulas is we're going to try to pick a formula that we feel like is matching the most complicated aspect, which for us is the denominator. Now, you might be thinking, great, but as you look at the list of formulas, there is no formula that has an exponent like a p to the fourth. So here's the other important piece of information you need to use when you're choosing a formula, is that if you see that your integral has an even exponent, like here we have z to the fourth, when you're picking a formula, keep in mind that that even exponent is representing where a p squared is going to be in the formula that you are choosing. Okay, so when I'm looking at my list of formulas, I'm expecting to see a p squared in this spot here. And I actually don't even care about the numerator right now. So I'm not going to be concerned that the numerator is going to match this numerator. I'm focusing on the denominator. I want a p squared here and probably something like maybe an a squared where I'm seeing that 9. Okay, so let's take a look and see if we can try to find a formula that's going to match that. And I wrote our problem 26 off to the side so we could kind of see it as we were glancing at these formulas. Okay, I want something that has a p squared in the denominator, maybe an a squared in front of it. Okay, as you glance through, gee, it really feels like maybe formula 16 is a good choice. See how that has an a squared minus p squared at the bottom. Now again, you'll notice the numerator is not matching the numerator here, but what we're doing is right now we're focusing on matching the more complicated aspect. I think that you're going to see how it's all going to work out in the end. Okay, so we're going to try formula 16. Very important that you guys are identifying that formula. And here would be my advice to you, because you're probably not going to be 100% confident that you have chosen the correct formula at the beginning. If you want to temporarily hold off from writing the right side of the formula until you have made the substitutions into the left side and you're confident that after having made the substitutions it matches the original, that would be okay. Okay, so I'm not going to write the right side just yet. I'll go back and fill that in a second. Okay, I'm now going to write down my substitutions. Okay, now the A is going to be a 3. That's easy. But you need to plug something in for the P. Okay, and you need to say to yourself, what could you plug in for this P so that after you've squared it, you're going to get a Z to the fourth. Okay, that's the question you're asking yourself here. Okay, so what we would need to plug in for a p so that after squaring it we get a z to the fourth would be a z squared. Okay, think about that. If you take z squared and then square it, that's going to give us what we want in that spot there, z to the fourth. Okay, anytime you make a variable substitution like this, you also have to take the derivative of both sides so that we can make a substitution in for the dp that we're seeing. So these are our 3 substitutions. I'm going to make those here on the left-hand side, and then we're going to see if this is going to kind of look like it's going to match our original integral that we have here. Okay, everybody follow my substitutions here. I stuck that z squared into the formula for the p, but then it said p squared here, so that's why that got squared. Okay, and then I'm swapping out the dp, and in place for that, you can see I put the 2z dz. Okay, so let's clean up what we have, see how this is going to look here. Looks like we've got a 9 minus z to the 4th, so that's good, that more complicated part's matching. Okay, and then I'm going to slide this 2z up into the numerator here, so that's going to make a 2z in the numerator. Now, the question I'm asking myself is, now, does this left side of the formula feel like it is matching what my original integral is? And it's really, really close, but it's not quite there. You can see the difference is we have this extra 2 in this problem. Now, if it's just a matter of adjusting a constant, that's pretty easy for us to make an adjustment to, okay? So if we've got this 2 here, all we need to do to kind of counteract that is to say, well, I'm going to multiply by 1/2, and that's going to cause that 2 to cancel. Okay. Now remember, anytime you're inserting something that's not there initially in an equation, you have to then do that exact same thing to the other side. So that 1/2 that I placed there in green, I immediately over here on the right side of the equation must multiply that side by 1/2. And if you remember here, I was kind of refraining from writing the right side just yet until I made sure that this was going to look exactly like the original problem, which now I've got it to look like that. So I'm going to go back and say formula 16 was definitely the correct formula to choose. So I'm going to fill in generically at first without my substitutions the right side of the formula. Whoops. Okay, and then I'll go ahead and make those substitutions. Okay, remember, let's see, our A's were 3's. Be careful with this. This is a P. Remember what we said P is. P is a Z squared. So we're plugging in Z squareds for those P's. This 1/2 is going to get distributed. Whoops, not to both of those. That's only one term there. Okay, I'm going to distribute this 1/2 to that. Okay, so I'm going to go ahead and write my answer down here. This is a 1/6, and then when I distribute a 1/2 to that, I'm going to get 1/12 natural log absolute value of this fraction that you see there. I kind of skipped writing that down here in this spot here. Okay, but there's the answer for number 26. So I think the key is if you can focus on matching the more complicated aspect and remembering that if you've got an even exponent, look for a p squared in that spot, you're going to be able to pick the correct formula. Okay, so let's try another one that you guys were wanting to see, number 29. Okay, and with those hints in mind, let's focus on looking at number 29. Clearly, the more complicated aspect is obviously the denominator. The other thing we would want to focus on is see how this e has an even exponent. There's a 2 there. That is a dead giveaway that I'm looking for a p squared in this spot. So as you glance at the formulas, we want a square root in the denominator. Probably this is going to be an a squared, and this is going to be minus a p squared. Okay, so as you glance through that, let's see if we can find a good fit. Now, again, if you look at formula 20, it has a square root in the denominator. It's got an a squared here. It's got a p squared. I know what you're thinking, but there's this extra p and there's not an extra p here. That's okay. At least this part here is matching and it's in the denominator. So let's go with formula 20 and see if that might not be a good fit here for this one. Okay, so we're going to say formula number 20. Okay, and just because maybe at this point we're not 100% sure, I'm going to start by just writing down the left side of the formula only. Okay, this was a plus or minus in the formula, but I'm choosing a minus because my original integral has a subtraction sign there. Okay, I'm going to write down my substitutions. Obviously, a would be a 2. Now here you got to be careful. You got to say to yourself, what is it that we should set p equal to so that after we square that, it's going to look like an e to the 2t. Okay, so we don't want p to be e to the 2t, because then if we square an e to the 2t, we're going to get e to the 4t. Okay, so we want p to just be an e to the t. That way, when you take e to the t and square it, you get e to the 2t, which is what we're after there. Okay, again, anytime we make a variable change, we got to take the derivative of both sides. Derivative of e to the t is e to the t. Okay, so let's make these substitutions, see how this looks here. Okay, now keep in mind, there is a p here, so I have to substitute an e to the t in for that. Okay, e to the t is going in there. I'm going to have a 2 squared there. Okay, here I'm doing e to the t squared. And then for the dp, I'm putting e to the t dt. Okay, because that dp, I'm putting it in here, is this. Okay, you follow that? All right, now let's take a look here. Now, if you're thinking, wait a second, this is going to slide over here in the numerator. If you look at the original, there was only a 1 there. Look closer. This e to the t is going to cancel out that extra e to the t that we really weren't liking that was there anyhow. And so when we clean this up, we see that we end up getting 1 over the square root of 4 minus e to the 2t dt. Okay, so past that, all you're going to do now is go back and write the right side of the formula generically, and then make all of these substitutions into the right side of the formula. And I think I've talked you through the most difficult aspect of that, so I'm hoping that you guys will be okay with, making those substitutions on the right-hand side and seeing how you get the answer in the back of the book, okay? So for the sake of time here, I'm going to just look at your last question. Number 37 was the last question that you guys were wanting to see here. Okay, and again, I'm not seeing an even exponent, and so when you don't see an even exponent, like these are just e to the 1t's, I would expect to just see a p in these spots, not a p squared. Okay, do you notice how you got a quantity and then another quantity? Okay, I'm going to pick a formula here that has those 2 quantities in the bottom, that has a p here and a p there as well. Okay, and I think a good choice for this would probably be, and this one is tricky, I'll give you that. The reason I'm going to go with formula 10, and I'm sure that a lot of you were thinking, why would you not pick formula 11? Okay, because the only difference is 11 has a p at the top and 10 has a 1, and if you look at this problem, whoops, you can see, well, that already has an e to the t there. Okay? But if you think the step ahead of what your substitution is going to be, and you let p be e to the t, look at what that's going to make dp be. Okay? We're going to have to substitute another e to the t dt in for the dp, and I think that's going to create this e to the t in the problem that wasn't there initially in formula 10. And if we pick 11, then we're in trouble because we've got 2 of those in the top. Okay? If what I'm saying there, I know that was kind of a mouthful. So I'm going to go with formula 10. Okay, I'm going to jot down the left side here real quick. I'm going to see how this hashes out. And, if it doesn't work out, we can go back and pick formula 11. Here's my substitution. A is 1, B is -1, C is 1, D is 1, P is e to the t, and dp is e to the t dt. Okay, so here's my substitutions. Looks like I get that. And that. Now here's the biggie. I'm going to change colors here so this kind of pops for you. Oh, this should have been a dp, my bad. For that dp, look at what I'm plugging in. E to the t dt. And so this slides over here and makes that a perfect match. Had I chosen formula 11, I would have already put an e to the t there. I would have had another one here, and then I would have had this issue of this being an e to the 2t. Okay, I think again there, that's probably enough of a push that you could then go through and go back to formula 10, kind of fill in with variables, and then make all these substitutions on the right side. Okay, hope that you guys are doing well. I miss all of you, and I'm getting a puppy in 2 weeks, so any advice that you guys want to give me, greatly appreciated. Bye.